activity 5.4 to 5.6. Again, we're going to talk about factoring trinomials, where our leading coefficient is 1. We'll start with that. And then we're going to talk about factoring by grouping still, we still have that. Factoring special factoring, like if we have a difference of squares, we saw that if we multiply conjugates, a plus b times a minus b, that gives us a difference of squares. So we're going to work backwards to use that. And then factoring squares of binomials. So we'll talk about all of those things. We're going to start off by factoring trinomials. That means that we have 3 terms. Usually it's a quadratic term. So x squared is the highest power of x. So factoring trinomials with a leading coefficient of 1. Okay, that means if we have x squared plus bx plus c. These types of problems always factor to the product of 2 binomials. You're going to get x plus m times x plus n. Okay, what is the relationship between the b and the c and the m and the n? Okay, m times n has to multiply together to give us c, and m plus n have to add together to give us b. So if we know, if we start off with x squared plus bx plus c, we're going to look for factors of c that add to b, and that'll give us our m and n. All right, let's practice that. Okay, there's some hints over here. Remember to factor out the greatest common factor first. So if there is a greatest common factor, factor that so that we have our x term, our x squared term with a coefficient of 1, and then use this technique. All right, so for the first example, x squared plus 10x plus 16, we want to factor this into 2 binomials. Since we have an x squared there, we know these first 2 terms are going to be x. And then the question is, what are the numbers that we're adding? So we want factors of 16, and we want them to add to 10. Let's list out the factors of 16. All right, factors of 16 would be 1 and 16. Is 1 plus 16 10? No, moving on. We have 2 and 8. Ta-da! 2 plus 8, 10. It does work, but just to be thorough, the other ones are 4 and 4. So 1 and 16 won't work. 4 and 4 won't work. But for 2 and 8, 2 plus 8 does equal 10. So ding, 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 this checks out. Our 2 numbers are, or our m and n, I'll say, are 2 and 8. It doesn't matter which one you call m and which one you call n. So this would be x plus 2 times x plus 8. And that's it. We'll stop here because we're just trying to factor this as much as possible. All right, so for the next 4 problems, we're going to use this same technique. Look at the C term. Think about all of its factors. Try to find a pair of factors that add to the B term. On to number 24. I'm sorry, number 24, number 2, which has C equal to negative 24. Now you have to be careful here with your negatives because we know one number is going to be positive and one's going to be negative. Which one has to be positive and negative to give us negative 5? And 24 has a ton of factors. I'm just going to list them. Now, if you can figure out the factors in your head really quickly without having to list them, perfectly fine. You can do that. All right, so let's start out by writing down the factors. 1 and 24, we know that won't work. They don't add to 25 either way. Then we have 2 and negative 12, or negative 12 and 2. Neither of those work. That'll give us, our negative 2 and positive 12. Those will give us negative 10 and 10. Then we have 3 and negative 8, or negative 8 and 3. Aha, these might work. 3, sorry, you guys, I keep doing the same thing, switching the order, but not the signs. 3 and negative 8, or negative 3 and positive 8. 3 and negative 8 give us negative 5 when we add them together. Negative 3 and 8 would give us a positive 5. What do we want? We want a negative 5. So these 2 factors work. You don't have to list out the rest of the factors once you find them to that work. So what does this mean as far as our 2 binomials? This is going to factor to an x plus 3 But since that 8 is negative, we're going to end up with an x minus 8. So x plus 3 and x minus 8. Remember, one very, very, very nice thing also, after you're done factoring, if you want to check your answer, just FOIL out what you've found as your answer and see if you get the original problem. So you can use FOILing to check your answer. All right. One more of these, problem number 3. We have 3x squared plus 15x plus 18. Here, we want to start off by factoring out the 3. That's the greatest common factor. And then we have x squared plus 15x plus, x squared plus 5x plus 6. And then in the parentheses, we're left with a trinomial that has a leading coefficient of 1. So this is going to factor to 3 times x plus something and x plus something else. This time, we're going to need the factors of 6 that add to 5. All right, factors of positive 6. So what two numbers can we multiply together to get 6? 1 and 6, that won't work. 1 plus 6
5
is
and
7.
1.
5 and 1 would multiply to give us 6. So what are the other two numbers? What other two numbers can we multiply to get 6?
And -1? No.
Slow down. Not that many numbers we can multiply to get 6. Two numbers we multiply together to get 6. Other than 1 and 6.
2 and 3.
2 and 3. Those are the ones that work.
There we go.
All right. So this would be, sorry, all of my color switching. 3 times x plus 2 times x plus 3. What if we have a trinomial with a leading term that's anything, or leading coefficient that's anything other than 1, and we can't factor out the greatest common factor? There's no greatest common factor to factor out. Okay, so the way that we can do that is another way of factoring by grouping called the AC method, okay? Remember last time we said, oh, we want to look at factors of C that add to B. Well, this time we're going to look for factors of A times C. So multiply A and C together. You want to find factors of A and C that add together to give you B. Okay, then there's an extra step here. Those numbers don't directly give us our answer. Those numbers tell us how we can break up the middle term. So basically, we're going to try to take the middle term, like in this case, we're going to take the 17x, and we want to break that up. We can say, oh, 17x is 3x plus 14x, or 17x is, various different things. Figure out a way that you can break up the 17, okay? We're going to do that using the m and n, and then we're going to use factoring by grouping. Okay? So let's practice that. For our first problem here, 3x squared plus 17x plus 10. 3 times 10 is equal to 30. So this is our A times C. All right, so we want to find factors of 30 that add to 17. All right, I found one. All right, so what are our factors of 30? You have 1 and 30, that won't work. And then 2 and 15, that does work, yay. All right, so 2 and 15 are our factors. And then what do we want to do? We want to take that 17x, and this is telling us that we can break it up as 2x plus 15x. So from here, we're gonna take the 2x squared, and then plus the 10x on the end, and in the middle, we're breaking up that 17. Okay, we can do it as plus 2x plus 15x, or we can do it, let's see if it works both ways, plus 2x plus 15x, okay? Factor on an x, yeah, this would work. And then we're gonna factor by grouping. All right, from the first two terms, 3x squared and 2x have an x in common. I factor out an x. That leaves me with a 3x plus 2. And then for 15x plus 10x, I can also factor out a 5 there. Okay, if I factor out a 5, that leaves me with 3x plus 2. So then when we're factoring by grouping, both of these terms have an 3x plus 2 in them. So now we can factor out the 3x plus 2. And we're left with 3x plus 2 times x plus 5. All right, quick little note. Note in the middle there, well, for my first step, hopefully we all agree that, when we multiply our a times c, we get 30. If we multiply 2 and 15, we get 30, and 2 and 15 add to 17. Why did I break up the 17 as 2x plus 15x? What if I did 15x plus 2x? Will it still work out? Yep, it should. So let's do that. We did 3x squared plus 17x plus 10. And we said, well, that equals 3x squared plus 15x plus 2x plus 10. Then when we group, we have different terms that we're grouping together. So will we get the same answer? Turns out we will. From the first terms, 3x squared plus 15x, we can factor out a 3x, and that leaves us with an x plus 5. From the second two terms, we can factor out a 2, and that leaves us with x plus 5. So now, both terms have an x plus 5. So if we factor out the x plus 5, we're left with 3x plus 2. So I just wanted to show this because once you find those two numbers that add to b, the question is always, well, does it matter how I arrange them? Sometimes one way is better than the other because it makes it easier to factor. But in general, no. You should be able to factor by grouping and get the same answer. For problem number 5, a times c. All right, a times c is equal to 12 times negative 3, which is negative 36. Be careful with your signs. And then you want factors of negative 36 that add to 5. The factors that work are 9 and negative 4. Okay, so we want to rewrite this problem as 12y squared plus 9y minus 4y minus 3. Now you can write it this way, but again, be careful when you have subtractions for your last two terms. When we group this, I'm going to say we're going to group it as 12y squared plus 9y plus negative 4y minus 3. Okay, then we can factor out a 3y from the first two terms. That leaves us with 4y plus 3. Okay, off to a good start so far. And from the second two terms, we can factor out a negative 1. That's all we can factor out as a negative. So that would be negative 1 times y plus 3. Then this gives us 4y plus 3 times 3y minus 1. And just to be thorough, again, if you break up the terms in the middle the opposite way, we get 12y squared minus 4y plus 9y minus 3. And if we group them together this way, we can factor out a 4y from both terms. So this is 4y times 3y plus 1 minus 1. That's not my signs today. Plus, we factor out a 3 times 3y minus 1. And then we factor out the 3y minus 1, and we get the same answer. So for the next group of problems, factoring trinomials with leading coefficient different than 1 by the trowel method. This is how I learned. I didn't learn the AC method until I started teaching. Basically, we're just guessing and checking, Okay, the factors, so again, we're trying to find the factors of A, and find factors of A and factors of C, and use trial and error to fill in the terms for the binomial. Okay, So what does that mean? If we have a 3x squared plus 7x plus 2, we know that these first two terms, whatever's here and whatever's here, have to multiply. I'm going to color code this, I'm sorry. Better colors, yellow. Whatever is here and whatever is here, this has to multiply together to give us the 3x squared. And then the last two terms, whatever is here and here, have to multiply together to give us 2. All right. So what are our options? There aren't very many in this one, so this is an easy one to guess and check. How can we multiply two terms together? The terms have to both involve an x, and we get 3x squared. Well, one of them has to be a 3x. And the other one has to be an x. That's our only option. And then the same thing is kind of similar for 2. What two numbers can we multiply together to get 2? 1 and 2. Now the question is, should the 1 go with the 3x or with the x? And that's where the guessing and checking kind of comes into play. So do we want a 3x plus 2 times x plus 1? Let's check to see if our middle terms end up being what we want them to be. If we did this, then we end up with, in the middle, or well, 3x squared plus 3x plus 2x plus 2. That gives us a 5x in the middle. So this actually does not work. So we know that we need the 2 to be with the x and the 1 to be with the 3x. And that's it. So you kind of go through a process. We think about what numbers or what terms we can multiply together to get the first term. Think about what things we can multiply together to get the last term, and then play around with the numbers so that the middle terms add up correctly. Okay, this does work out. If we check it, we get 3x squared plus 6x plus 1x plus 2, which is 3x squared plus 7x plus 2. So you just thinking about what the factors could be and kind of guessing and checking until you find the correct things that add up in the middle. Again, we're using the trial method, or guess and check is what I usually call it, for factoring 2x squared plus 9x plus 4. So we're going to break this into two binomials. The first two terms have to multiply together to give me 2x squared, 2x and x. So for 2x squared, we can have 2x and x. That's pretty much it. For 4, we have a few options. You can have 1 and 4, 4 and 1, or 2 and 2. We need to figure out which combination works best for us. All right. So let's guess and check. If we did the 1 and 4, the 1 and the 4 works. Let's check the other ones to make sure they don't work. So let's say you looked at this and then you said, oh, well, 2 times 2 is equal to 4. Let's try that. Plus 2 plus 2. If we check it, we get 2x squared. Great. Plus 4x plus 2x, doom, 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 plus 4. That doesn't work. All right. If we check the other one, 2x plus 4 times x plus 1. That gives us 2x squared plus 2x plus 4x, doom, 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 plus 4. Another issue that doesn't work. So then the last one, ding, 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 the one that does work. 2x plus 1 times x plus 4. Why does this one work? Because now the 2x is being multiplied by the 4. So we get an 8x plus 1x in the middle. That one worked. So our factorization here was 2x plus 1 times x plus 4. But when we're thinking about factoring, when we first look at a problem, we want to think, can I factor out the greatest common factor? If so, do that. If you can't factor out a greatest common factor, then your next thing will be, okay, then what's A times C? Do I want to factor this by grouping or using the guess and check method? It's up to you. I'm sorry. Yeah, I am going to, for this one, use factoring by grouping. But you are welcome to use a trial and error method. It's up to you. And then follow through with whatever method you choose. So for problem 8 here, we cannot factor out a -5 from all of these terms. Since we can't factor out a -5 from all of the terms, we need to move on to try to factor by grouping. If we multiply a times c here, that's -5 times -4, which is 20. And we want factors of 20 that add to -21. So that already tells us that we want negative factors because we need a -21 in the middle. Okay, the ones that will work. We have obviously 20 times 1 would be 20, but -1 times -20 also works. Those are the two that we need. So we are going to break that -21 up, 21y in the middle. We're going to break that up as -y minus 20y. All right, let's see what we get. Is there a question? I hear someone unmuted. All right, then I'm going to mute you because there's background noise. And you can just unmute yourself whenever you do have a question. All right, so -5y squared. Again, the minus 21y is minus y minus 20y, and then minus a 4. Be careful here with how you are grouping. We're going to group together the first terms, -5y squared minus y, and then plus the second two terms, -20y minus 4. And then when we factor, we can factor out a -y from the first term. Okay, and then that'll leave us with 5y plus 1. And from the second term, we can factor out a -4. Okay, and that leaves us with 5y plus 1. I see. Made a bit of an error in the beginning. Well, I wouldn't say it's an error. There was something that we could have done in the beginning that would make this slightly easier, but it's okay. When we factor out again, we get 5y plus 1 times -y minus 4. Now, we don't usually end up with terms with a -y, right? That's because we could factor out an extra negative here. So from that second term, the -y minus 4, we can factor out a -1, and we can write this as -y plus 4 times 5y plus 1. There are some formats that we have special rules for factoring. The first one that we're going to look at is the difference of squares. In the last class, we looked at multiplying to conjugates, and we had a pattern for that. Now we're going the other way. When we multiply a minus b times a plus b, we get a squared minus b squared. So we can say now that if we have the difference of squares, first term is a square minus the second term is a square, then that's going to factor to the conjugates. Okay, so for number 9, x squared minus 81. This is x squared minus 9 squared. So our a in this case is x, and our b is the 9. And then by the difference of squares, this is going to be x plus 9 times x minus 9. And that's it. And this works anytime you have a difference of squares. Part 10 works out similarly. Be careful there. We have 9x squared. So the 9 is a square and the x is a square. This is 3x all squared. And then 36 is 6 squared. So in this case, this will factor to 3x plus 6 times 3x minus 6. Right. Notice the similarities and differences between 9, 10, and 11. For 9, we didn't have any coefficient in front of that x squared term, so it's clear that to see that we have x and x for our first two terms in the binomials. For number 10, we have a 9x squared, but that worked out nicely because 9 is also a square. So 9x squared is just 3x all squared. However, for number 11, we have 20x squared. Is 20 a perfect square? No, 20 is not. The x squared is fine, but the 20 is giving us a problem. This is an example of where we want to first factor out the greatest common factor and then see what's left and if we have a difference of squares. So if we factor out a 20, we would have 20 times x squared minus 320 divided by 20 is 16. And then, now in parentheses there, we do have a difference of squares. This is 20 times x squared minus 4 squared. And the x squared minus 4 squared factors to x plus 4 times x minus 4. For 12, we have x squared plus 16. Can anyone tell me how to factor this one? Go ahead, Nick. I saw your hand. Can't hear you.
I'm gonna say x plus 4 and x plus 4.
X plus 4 times x plus 4.
X minus 4.
X plus 4 times x minus 4.
No, x plus 4 times x plus 4.
So are we guessing or do we know which one?
X plus 4 times x plus 4.
All right, x plus 4 times x plus 4 would be x squared plus 8x plus 8x plus 16, which is x squared plus 16x plus 16. So that does not work. This actually matches up with what we have here. Why doesn't it work here? Why aren't we using the difference of squares? Because that's not a difference. Don't fall into my traps, you guys. Don't fall. Okay. So it has to be a difference of squares. This one is a sum of squares. And there is no rule for factoring a sum of squares. This doesn't factor anymore. For the next part, there are some patterns that we see when we square a binomial. So something like a plus b squared and a minus b squared. In the last class, we talked about how to multiply these things, and we get a squared. If we have a plus b squared, we get a squared plus 2 times a times b plus b squared. If we have a minus b squared, we get a squared minus 2 times a times b plus b squared. These are called perfect square trinomials. So if you see a trinomial where the middle term is 2 times a times b, so 2 times, what's a good way to do it? The square root of a and the square root of the a term and the square root of the c term. That's really what it is. If you see something that has that pattern, we know that it's this situation. For problem 13, we have x squared plus 6x plus 9. In this case, a is equal to 1 and b is equal to 3. Okay, so this would be 1x squared plus 2 times 1 times 3x plus 3 squared. I'm just trying to show you how this matches up with the rule. And it does. 6 is 2 times 1 times 3, so this matches up. That tells us that this is just going to simplify to a plus b all squared. So this would be x plus 3 all squared. If it's hard for you to visualize that pattern, remember you can always use our other factoring techniques to factor this trinomial too. We want factors of 9 that add to 3. This would be factors of 9 that add to 6. That would be 3 plus 3. So x plus 3 times x plus 3. That gives us x plus 3 squared. So for number 14, we have our a term. I'm sorry, I wrote this incorrectly over here. I would like to fix it. Our a term is x here for problem 13 because the x is being squared. B term is 9, or the B term is 3 because the 3 is being squared. So 14 we can say is x squared and then minus 16 is 4 squared and 8 is 2 times 4. So minus 2 times 4 times x plus 4 squared. Again, this one looks like our second option here. Our term in the middle is being subtracted. So we have a squared minus 2ab plus b squared. Okay. Then this will multiply or factor to, I'm sorry, x plus 4 all squared. And again, if you want to, you can use the other technique, x squared minus 8x plus 16. We want factors of 16 that add to -8. I messed up. I just realized that should be a -4. I'm so sorry, you guys. It's like 2 mistakes in a row. I'm done with mistakes for the rest of class. All right, that should be a -4 there though. But factors of 16 that add to -8 would be -4 and -4. So this factors to x minus 4 times x minus 4, which is of course x minus 4 squared. All right, these aren't that bad because the first term is x or x squared. But when we get to problems like 15 or 17, it's nice to notice the patterns that we're given for the factoring of perfect square trinomials, because we have coefficients for our squared terms that aren't 1. All right, so for problem 15, we have 9m squared. That would be 3m all squared. 4p squared would be 4p all squared. And then in the middle, 12mp. I'm sorry, wrong again. This is 2p all squared. All right, and in the middle, 12 is 2 times 2m times, 2p times 3m. It does work out. All right, the way that I think about doing this to just show that it works for the rule, it should be easier to factor the first term and the last term into squares. And then that tells you what your a and your b are. And then you just want to check to make sure the middle is a times b times 2. And it does work out. Okay, so here a is the 3m, b is the 2p, and this would factor to 3m minus 2p. It's minus because those middle terms are being subtracted, all squared. All right, let's try this again. Last one. Well, not last one. First one with 0 typos on my behalf. So if we look at the first term, 100x squared. 100x squared is 10x all squared. So a is equal to 10x. And then 16 is 4 squared. So b is equal to 4. And then in the middle, we have 80x. Okay, is this 2 times 4 times 10x? Ask yourself that question. It is. That's 2 times 4 times 10 is 80 times x. So this works out. This would factor to 10x minus 4 all squared. This one is not a perfect square, because these two last terms are just both x terms. So we can simplify this a little bit. 80 minus 25 would be what, 55? So this would be equal to, well, the way it's written is not a perfect square. 64x squared minus 55x. Then what can we do? We can factor out an x, but that's it. Yeah. Not as exciting as I thought it would be. All right, so if we factor out an x, that's just 64, x times 64x minus 55. So for number 18, we have 4p squared, that's 2p all squared, and then minus 169 here. You go back to the rule. Where is it? All the way up here. This b term needs to be positive. So this is minus 13 squared, and then plus 2 times, does this work? Yeah, 2 times 2p times 13. That actually does work in the middle, but because this last term is being subtracted, this is not a perfect square trinomial. All right, last two. This is another one that has a long formula that we'd have to be able to quickly recognize or use. If we have the sum or difference of cubes. So we have two rules for cubes, sum rule and a difference rule. They are similar, but notice the differences in the signs. So if we have the sum of two cubes, a cubed plus b cubed, identify your a and b, and then it's factors to a plus b times a squared minus ab plus b squared. Okay. Notice that if we have a minus b, a cubed minus b cubed, that's a minus b times a squared plus ab plus b squared. So notice the differences here. I'll try to circle it. When you have a sum of cubes, the first term is added. And then in the second, the first terms are added. In the second terms, the middle term, the AB, is being subtracted. We have a difference of cubes, the A minus B, the first term is subtracted, first terms are subtracted, then the second group of terms are all being added. All right, we're gonna keep that here and then do problems 19 and 20. 19 is the sum of cubes, 20 is the difference of cubes. For 19, we have x cubed, so our A term is x, plus 8 is 2 cubed. Okay, so A equals x, B equals 2, and using our formula for the sum of cubes, this would be x plus 2, that's A plus B, times x squared minus AB, so I'm going to write it as BA, 2x, and then plus B squared, that would be 2 squared, which is 4. Just to be a little bit more thorough, I want to show you guys where all of this comes. I want to do it directly so you can see where it comes from. So we have x squared times a times b is x times 2, and then plus 2 squared. All right, so that's x plus 2 times x squared minus 2x plus 4. And that's our final answer for that one. Yes. All right, for the second one, 27x to the third minus 64y to the third. 27 is 3 cubed, so this is 3x all cubed, and 64 is 4 cubed minus 4y all cubed. So this is a difference of cubes where our a term is 3x and our b term is 4y. According to the formula, this would be 3x minus 4y. All right, that's the first part. And then times 3x all squared minus, or plus, 3x times 4y, and then plus 4y all squared. All right, now let's be careful with our simplifying here. We have 3x minus 4y, and then times 9x squared plus 12xy plus 16y squared. And that would be our final answer. We made it through all of our factoring for today. All right, so we learned how to factor when our coefficient, or factor our trinomial with the coefficient, leading coefficient of 1, using the AC method or by using trial and error. We also talked about factoring trinomials without a coefficient of 1 using the AC method. Then we talked about the difference of squares, and then the sum and difference of cubes, and then factoring perfect square trinomials.